Okay, I've got 4 o'clock, so we will go ahead and get started. We are going to go over the sample exam for Wednesday, but I want to talk about Lab 10 first. Lab 10 is out. It is about classes and object-oriented programming in Python. We're going to talk about that and give you enough detail that you should be able to sail through it easily. And then we'll get to the sample exam. Okay. Reminder, the exam is during the class period on Wednesday on Blackboard. It's similar to exam 1. It's 75 points. You have some true, false, some multiple choice, some short answers, some short debugging, and some programming. And, you know, if you haven't had a chance to go through the sample exam yet, it is available. As far as Lab 10, okay, here is the assignment for Lab 10. If you've in Jeff's class and you've had it this morning, Jeff went through this. Tommy is going to go through this Wednesday. As I said, what I want to do today is go through this to the extent that you'll be able to sail through this lab. They can help with any questions. And then after I do that, so this won't take a huge chunk of this lecture, but after that, we'll go back to reviewing the sample exam. So, object-oriented programming. Now, again, this material is not on the test, so it's just the lab for today. You hear a lot in software about the buzzwords like object-oriented programming, classes, objects. You know, what does this mean? What it is a style of programming that uses abstractions, okay? Abstractions called objects that make programming easier by making it easier for the programmer to think about what should be done and what should not be done, okay? If you think about one of the things we're going to talk about and one of the things that's described in the lab, there's car. Now, if I tell you about a car, you understand it has certain things, right? It has an engine type. Is it gas, diesel, hybrid, electric? Is it 4-cylinder, 8-cylinder, what kind of battery? You understand that a car has an engine type. Speed, how fast will it go? I mean, if you're driving a Porsche 911, that's probably different from a, smart car. Fuel consumption. What kind of range can you get? If it's a battery, how far can you go on one charge? If it's gasoline, how far can you go on a tank of gas? How many miles per gallon and how big a gallon? How many seats does it have? Is it a 2-seater smart car or is it a 8-seater minivan? When you think about cars, you think about all of these things. And if we're programming about cars, it helps to think of the car as a single object and talk about properties of it or methods of it, okay? So that's the idea. An object or a class of objects is just something that abstractly has properties that we can deal with that makes programming easier. Every programming language is different. If you've done programming in other languages, you've run into this. If you've seen in C++, C++ is all object-oriented, essentially. Python is somewhat unique among modern languages. It is not really inherently an object-oriented language. Most Python programming can be done without being object-oriented. Classes are not a fundamental part of Python. They're actually a fairly recent addition. You can do all or most of your programming in Python without ever getting into classes or objects, and a lot of people do. A lot of people who use Python to do machine learning or artificial intelligence or data and analytics or whatever will get into classes. But since this is a first programming course, we want to introduce you to the topic of object-oriented programming. We want to introduce you to the topic of classes, and so that's why we have this lab and this part of this lecture. All right. We've talked about lists in Python as a data structure. We've talked about dictionaries in Python as a data structure. We've talked about functions as a way to set aside code and do blocks of code. Classes are kind of the same idea. Okay, if you're going to do a class in Python, you have to define it. The reserved word is class, and then you follow that by the name of the class, which can be any valid Python variable name. Now, in Comp Sci 201 at UMBC, we define class names using what's called upper camel case. Now, camel case means that just the first letters of each word, the words are all run together in the name, and the first letters of the word are capitalized. Okay, that's just a hint. That's a style. Python doesn't care about that, but Comp Sci 201 at UMBC does. That's just a style guide to let people know this is a class, right? If it's all caps, it's a constant. Python doesn't enforce that, but we do. If it's a variable, it's snake case. Python doesn't enforce that, but we do. Snake being use underscores to run the words, to connect the words together, run them together. Camel case, it's just each word has an uppercase letter, and yeah, the notion is this is sort of like a camel in that, you know, you've got a hump in the middle every time you get an uppercase letter in your word. Okay, so in the simplest case, if I'm going to define a class, I have the Python reserved word class. Then I have the name of the class, my class, upper camel case, uppercase M, uppercase C, colon. Everything has to have a colon at the end of it. Then very Pythonic, we have indentation. Right, class, my class, indent, and then a comment, just whatever makes up your class. We're going to go into some more details on that. And then maybe an assignment. Now, within a class, you can have code such as a function. You can define a function that only applies to a class, and we call that a method. Now, method, you've heard the word before. It's a little bit different here, but a function defined in a class only operates on members of the class. It's not useful in the entire program. And so we call that a method that operates on the function. Now let's do something more serious. Okay. If I just want to create an object that's an instance of a class, create something that's of type my class, I just say X equals my class. It's an empty object, and that's not particularly useful. So let's get back to our car idea and show how we use the constructor method. Okay, so this is the code that we have going to PyCharm that's on that slide. Class car, uppercase, colon, indented. Now, this particular wording, this particular construct is called the constructor method, no pun intended, double use of construct. This is called the constructor method. Def, that's our function definition, right? We've seen this before, function definition, def. Underscore, underscore, init, underscore, underscore. So there's two underscores here on each side of init. That's like our if underscore, underscore name, right? Parentheses. Now, in this case, we've just got the simplest thing, the word self. This is the constructor, and what this says is anytime I define a car, okay, anytime I define something of class car in my program, it's going to have these components. It's going to have these parts to it. It's going to have something called make. It's going to have something called model. It's going to have something called VIN, or vehicle identification number. Every car manufactured in the United States has a globally unique vehicle identification number, so we can say this is your car if there's a question of that stolen or whatever. And cars that are legally driven on the road have license plates. Okay, so this is called a constructor method. The def init on down to the end, this is called the constructor method. Anytime I define an object, an instance of class car, it's going to have these values. Okay, so let's copy this down into our Python console, overwrite what I was doing before. Now, that defines, I have to have that code in my program. Now, how do I use that code in my program to do something about it? Well, I can say that a car is a car. Okay, I now have something in my program, a variable in my program called a car. A car has all of these fields, and because I've assigned values, it has these values. Okay, so a car dot make has the value Toyota. A car dot model. What did I do wrong? I misspelled something. Is a Camry, and so on. If I say print a car dot model, a car dot make, let's do this in the right order, make a car dot model, a car dot VIN, a car dot license plate, and if I haven't made any typos, this is what I get. So this is a way to create a class car, defined right here, and to create an instance of it, and it has these values that I can use throughout my program. But of course, that's not really a useful thing, because doing it this way says every car is a Toyota Camry with this vehicle ID number and this license plate. There is, in effect, only one car on the planet. That's not useful. Here is a more useful definition. This is a way of defining the class car. Again, our constructor method, define underscore underscore init underscore underscore self, our magic word self again. Now I'm going to pass it parameters, just as I pass functions. Okay, we've covered functions, so you know functions, and you understand parameters in functions. We have def, we're defining a function. This is a special function called a constructor of a class. That's the underscore init stuff. It has self, and now it has the parameters make, model, VIN, and license plates. These values are going to be passed to the constructor when I create an object. Just like when I call a function, I pass arguments and I pass values to the function parameters through the arguments. I'm going to pass the values of the car through these. And I'm going to say the fields of the class car are, again, make, model, VIN, and license plates. And here is where they're going to get their values. I'm just going to take these arguments and pass them. Now, in this case, I use the same words, make, model, VIN, and license plate for the arguments. I don't have to. If I want this to just be ID and this to just be ID, that works too. Doesn't matter, right? But this is how I define an object. This is my constructor now for a more general type of car. Okay, so I've got it defined. Now, how am I going to define it? Previously, if you went up here, you see I defined it by saying a car is an instance of class car. That was the previous definition where I didn't have any parameters. I didn't have any arguments. I didn't have to pass anything. My current definition, I'm using this one. Ignore self. You can see I have to pass in make, model, ID, and license plate. So the syntax is my car is a car, and I'm going to pass in 4 arguments. Toyota, the string Toyota, the string Corolla, the string 1, 2, 3, 4, 5, and the string Go Dogs is my license plate number. Okay. And since one of my daughters is a UMBC grad and one of my daughters is a College Park grad, I'll create another car called Your Car, which is a Honda CR-V. It has this unique vehicle ID number, and her license plate is Go Terps. Now I have 2 different variables, each of which is a car, and it has these properties. What is mycar.make? Mycar.make is a Toyota. What is your car dot make? Your car dot make is a Honda. What is my car license plate? Go Dogs. Your car license plate says Go Terps. Okay, so what I have here is a class definition that says I have a car. When I create a car, it has a make, it has a model, it has a VIN, and it has a license plate. That's the general frame. When I create my car now, I have my car with these values, and I have your car with those values. So this is how you get set up to start doing it in Lab 10. And we're actually going to work through Lab 10 a little bit to get through this. Okay. That code's going to let you define an object of class car. This is the first one we showed. This is a more generic one with the skeleton. Man, this really doesn't show well. Okay. But what I'm doing is, this is what I've just shown you. I've got a class car, make, model, VIN, or ID, or whatever, license plate. Here's the values. You create the car. It looks like a function call. It looks like a function call, except it has this syntax. We map the arguments to the parameters. Now you can access those variables, as I showed you in PyCharm, by using the field number, the field name, make, model, VIN. Methods. I sort of mentioned a little while ago that I can define a function inside of a class, and it's only valid for those members of the class. When you define a function inside of a class, when you define a method that operates on the class, it is only valid for members of that class. You can have other variables in your program. That function is unknown. The function you define inside a class is unknown for any object that is not part of this particular class. So, getting back to the problem, because this is what's illustrated in Lab 10. Okay. I'm going to change my definition of car. I'll come down here and copy it again. And again, I'll post all these slides when I get a chance. And also the lecture notes. We're going to add another field to this. Passengers. And passengers is just going to be a list of people who are riding in the car. Now I'm going to define another class, which is the class passenger. And let's make sure I do this consistently with the lab explanation. Okay. Okay, here we go. Let's get this right. Okay, passenger. Def init, my constructor method for passenger, has no parameter. It has a parameter name in addition to self. And self.name is equal to name. So a passenger has a name. It's going to get the value that's passed in. Okay, so I have these two class definitions. Now, what I can do is I can define a method for car by putting another function inside my class car definition. Okay, put a blank line there. I'm going to say def add passenger and again, make sure I get my syntax correct. Okay. I will add a passenger to my car by appending a passenger to the list. Remember, passengers is a list, so when I add a passenger to my car, I'm going to do it by appending the name of a passenger to my list of passengers. And again, a passenger down here is just going to be a name. Okay, this is shown in Lab 10. Okay. So now, when I want to add a passenger to my car, the code looks like this. In my main program, Eric is a variable name. Says to create Eric, create a passenger, an object of class passenger, whose name is the string Eric, and then add that to my car. So let's take this code. Down to our Python console. And presuming I haven't made any errors, it will actually, looks like it will actually work. Now, my car Toyota Camry 1 2 3 4 5. Go dogs. Okay, fine. Now, my car dot add passenger. Let's create the Eric first. Eric. My car dot add passenger Eric. Now we're adding the variable name, not directly the string. So now, what is the value of my car? It's an object. Print my car dot passengers. Okay, that's an object of type passenger because Eric is not a string; it's an object of type passenger, but it's in there. Okay, so this is how we created an object. Now let's turn to the lab. Okay, what I have done is tried to work through the examples that we give you in parts 1A, 1B, 1C, etc. of the lab assignment, so hopefully you can work through them. How to access the variables, how to do things like that. Adding a method just says, hey, here's how to write another function inside of your class. So adding methods, these are just functions that are inside your class that can operate on objects in your class. We've given you fill tank and drive miles. Okay. Please skip part 1F of the lab for now. When the test is over and your lab is complete and your lab is submitted and you have extra time on your hands, then you can read part 1F of the lab assignment and start playing around with it. It's interesting stuff. It's good stuff. As a geek myself, I think it's cool. You do not have to use it for the lab. It's not needed. It's certainly not on the test. So please, for your sanity as well as mine, skip part 1F of the assignment for now. You can get back to it after you submitted the lab. Okay, so the class's exercise, you're going to take code that's given and you're going to write the class definitions. Okay, The starter code is there, and let's see if I can find it. Let me see if I can share a terminal with you. There's a terminal. Okay. Here we go. What I've done is I've downloaded and I'm displaying, and let's see if I can make it bigger. When you've downloaded the file, boxes and items.py, it looks like this. Now, the pass statement does nothing. It's a no-op. It just says, don't do anything, continue running. It lets this program work without dying because it's nothing under box. So we have a header for class box and a header for class item. And your assignment in Lab 10 is to write the code that goes under class box and to write the code that goes under class item. You will have to write the init functions. You will have to do def __ init __ for box and def __ init _ for item. You will have to write them. We've given you the main program. The main program implements the function designed. This is what it looks like. So we've given you the main program that goes through and does everything. What you have to do in Lab 10 is write this code that goes under box and this code that goes under item. That's what your assignment is in Lab 10. Okay? So that's all you have to do. It can appear daunting. It's actually not that bad. You have to write a display method for boxes, a display method for items. All this does is print, right? You have to define a function that prints. That's real easy. You know how to do it if you get past the mental issue of this is new, this is methods, this is object-oriented, I don't know this before. Yeah, you know how to write a function that prints out boxes. Same thing with display. You know how to write a function that prints out items. You can do that. Okay. You'll have to write create item length, name, length, width, and height. Okay. That's an init. This is what's going to go in init. You're going to have to be able to create a box. Place an item into box. This is fairly straightforward. This just adds an item to a list. Remove it. This just removes an item for a list. And quit. This exits the program. Okay. So these methods are what you're going to have to write that go under class box and class item. And I'll give you a hint. This goes under class box. This goes under class items. This goes under class items. This goes under class box. That's 2 each. This goes under class box. And this goes under class box. You've got 4 things you have to write under box, 2 things you have to write under item. When you figure out exactly what they are, they're really straightforward. It's not that bad. You certainly can ask for help. It's available. That's not due till Friday night. So if you want to wait until after the exam to work on it, that's fine. As I said, if you're in Jeff's lab, he talked about this today. If you're in Tommy's lab, you're going to talk about it on Wednesday. That'll give you a little bit more clue. Ask questions. If you're in Tommy's lab on Wednesday and he starts going through this and you have looked at it a little bit and have a couple of questions, hey, ask him. Get it done in class on Wednesday. That's fine. What I just wanted to do with this part of the lecture was give you enough information in the background to make you understand this is really a terminology thing. We have not talked about classes and objects and methods in this sense in terminology. But other than that, you've done all this. Just writing short functions, 2 or 3 lines of code. That's it. You're using the syntax to define a class. You're writing 2 or 3 lines of code to do a function to print out something. It's not a big deal. All right. With that, I wanted to get to the sample exam. and go through all of the answers to that. So let's see if I can figure out where I put the sample exam. Here we go. All right, here we go, PDF. This is the sample exam. Now, the way I set it up on Blackboard, you may not get the multiple choice answers displayed in the same order. It turns out Blackboard gives me the option of having the A, B, C, and D displayed in random order. So for the sample, I fooled around with it. So if you did the sample exam and it popped up in a different order, don't worry about it. It's what the correct answer is. So multiple choice, first question. Which of the following would be a good time to use a while loop with a sentinel value? Remember what that is. A sentinel value says we're looking for something specific. Type 0 to exit. When there's something in a data file to indicate it's the end of file. Anything like that. So, when you're reading data entered by a user, you don't know in advance how much you're going to be, this didn't come across well, how much you're going to be reading, and you're waiting to tell the user is going to enter a specific value to quit. So the answer here is this one. This is the correct answer. When you know you want to read a specific number of items in from a data values in from a user, no, that's a for loop. You know you're going to read them in. I mean, you could do a while loop with that, but it's not a sentinel. That's a read a specific number. When you want to perform an item on each in a list, no, that's a for each loop. This is a for each loop. Okay. When you want to read a file into a single string, no, that's got nothing to do with a loop at all. There's no sentinel value when you're reading in a file all at once. That's just a read statement. Okay. So the correct answer to this question is A. What you should know, sentinel value means you're running your loop looking for a specific value to be typed in or to be read in from the file, and that's what's going to make you break out of the loop. Okay. Gee, sorry about that. It just did not come across well at all. If race results is a two-dimensional list, results I and J refers to the element in column I, row J. That's false, should be corrected. What did I do wrong? This is the first is always the row, and the second is always the column. This should be false, is the correct answer here. Okay. First is row, second is column. That's what you need to know. Third question. Every problem that can be solved with a recursive program can also be solved with an iterative program. That is true. Talked about that last week. If you can do it with recursion, you can do it iteratively. The reverse is not true. This one is true. Suppose we have a file race results and the program includes the statement with open race results.text R as F. Which statement will read one line from the file? The answer is B, read line. Data equals F dot read line. F, because F is defined, is the variable. Right here, we assigned to the file name, so that's F. Read line reads one line. Read reads the entire file into a single string. We don't want to do that. Read lines reads the entire file into a list of strings, and none of the above is incorrect. The answer is read line. So read line, singular, will read a single line. Okay, next one, number 5. A two-dimensional list can be initialized using the statement 2D list equals 2. Or how did this get set to true as the default answer? This is also false. You initialize a 2D list the same way you initialize a 1D list. A single set of square brackets. That, which is highlighted, is the correct way to do this. So false is the correct answer to this one. Okay, number 6. If states is a two-dimensional list, length of states represents the number of columns in states. That's when I actually mark correctly. This is false. If this is a two-dimensional list, length of the two-dimensional list is the number of rows. Length of the 2D list is the number of rows. So this statement is false. This is actually the correct answer, Mark. 7. Which of the following data types are mutable in Python? The only ones we've talked about that are mutable are dictionaries and lists. Dictionaries and lists are mutable. Everything else we've talked about are immutable. Okay? Mutable can be changed after initialized. Immutable cannot be changed after initialized. Integers are immutable. They cannot be changed. When I say a equals a plus 1, Python gets a new location in memory, calculates the value to put there, throws the old location in memory away. It does not change the value of that location in memory. It gets a whole new location in memory to work with. It's a whole new object, if you will. Dictionaries and lists, you can change them on the fly in the program without changing memory. They are the only two that are mutable. Number 8. A dictionary has no order. It establishes a relationship between keys and values instead of a relationship between index and value. This is true. Talked about that. Lists, relationship between a value and an index, where it is in the list. Dictionary, relationship between keys and values. Dictionaries are unordered. 9. Suppose that we have a dictionary, dogs. Snoopy is owned by Charlie Brown. Lassie is owned by Timmy. Benji is owned by Joe and Jane. And Odie is owned by John. Which of the following would you use to print out the keys in the dictionary? For K in dogs.keys, print K. Okay. Print dogs.keys, you get an object back. Okay, you get an object back if you just try to print the keys. This statement gets the values. This statement gets the actual entries out of there and prints them. So the answer is this first one would print out the keys. Okay, values you don't want to. We don't want values, we want keys. And the last one, print dogs.keys. Again, this gives you an object. You want to print keys, the individual elements and keys, you have to do it this way. That is the multiple choice. Now, in this particular case, debugging came up next in order. This is the same as the first one. Identify at least 5 errors in the following program, the line number, and tell what you did. Boy, I haven't looked this in a while. Let's figure out. I've defined a function, getKeysD, and here's the first problem. There is no colon at the end of line 1. So first error, at the end of line 1, I need a colon. Next one, list of keys equals an empty list. Good. For key in D.keys, okay, assuming D is a dictionary, this is fine. List of keys dot append key, that looks good. Return list of keys. So in my function, I'm taking D, which must be a dictionary. I'm returning a list. Got it. Let's check to make sure we have the right. Def get values. Return D dot values. So I'm taking a dictionary and I'm returning an object that consists of values. Now we're in the main program. Cats is a dictionary. Simba's a lion. Garfield's a tabby. Bagheera is a panther. Boris is a tabby. And Shungon is a Siamese. Okay. Here's an error right here. I have a semicolon in between this, Simba being a lion, and Garfield being a tabby. It is a comma. It should be a comma. So syntax error number 2, this is a semicolon. It should be a comma. Okay. Fine. while length of cat's keys, this is invalid, right? This is a number. The length of cat's dot keys is actually going to be 1, 2, 3, 4, 5. This says while 5. While 5 is going to be an infinite loop. We should never do this. So this is a third error. You shouldn't do that. You know, while length of cat's keys is what? Greater than 0, less than 10. You know, give me a Boolean, not a number. List of cats equals get keys of cats. Call up to here, dictionary, that's fine. Get a dictionary back, that's fine. Print remaining cats, colon, get values cats. Okay. I'm going to have a problem because get values is going to return d dot values, which is not a printable thing. So an error would be you're not going to get anything useful. You will, in fact, get a printed statement that says this is an object, not anything useful out of it. Okay? But that's in the while loop. And again, this is an infinite loop because this never changes. Okay? This never changes. This says while 5. Well, 5 is still 5. 5 is always 5. Cats.pop, list of cats. This is unindented, so it's not part of the list. Okay, this is not part of the while loop, so I'm not actually changing my list of cats. Print program finished. So the errors are, there's colon missing up here at the definition of get keys. In my dictionary definition, there's a comma. It should be a comma instead of the semicolon. This while loop is not a Boolean condition. This is an integer, which is considered to always be true. That's going to cause a problem. This is an infinite loop because inside the loop, I never change anything. This is not going to print out anything meaningful because of the way values works. Okay. This is not indented, and I would accept all of those as errors in the program. Question hit. Oh, missed an error. There are 4 underscores missing in the if underscore name main. Thank you. Let's go double check. You are correct. Thank you, Luke. That should be if underscore name underscore. That's just if name. So that's not going to be the special reserved word, so Python wouldn't know how to do it. That's correct. There's an error as well there. It has to be underscore name. Okay. Let's get to the short answer. Write a sentinel-based while loop that prompts a user to enter a deposit amount and continues until, and we looked at it and see what that was actually supposed to be. Hang on. Okay. Okay, let's get through this. All right. Run until the user enters 0.0. We're not going to validate inputs. The user's only going to enter non-negative, 0 or greater floating point numbers. You don't have to write the whole program, just the loop. So the sentinel we're looking for is 0.0. So what we're going to do for this particular loop, for this question is, we're going to say deposit equals input or float input enter deposit amount 0.0 to stop. Okay, we have to do this. Since it's a while loop, we have to do a priming read. This line of code is our priming read. It gets the initial value. While deposit is not equal to 0.0, do something, and then read in the next value. Deposit is equal to float of input. Enter deposit amount 0.0 to stop. What I'm looking for is that you know a sentinel value is something like this. You're looking to see whether, looking for that 0.0 to stop. I'm looking to make sure that you have a priming read so you get a value first. Because if you don't have this highlighted line of code, when you get to this while statement, right, you have no value, deposit's undefined. So you have to have some value. And then you're getting the next value, so you're not in an infinite loop. That's what I would be looking for in that particular problem. That's all you need to say. Explain the difference between a parameter and an argument when dealing with Python functions. The argument is what the main program passes. The parameter is how the function refers to it. Main program, call, argument. Function, take value process, parameter. That's the difference. Argument, main program, parameter, function. 13, I give you a list of the states. I give you a list which consists of the 50 states of the United States. The question is, write a for each loop that will print out each state's name if and only if that state name ends with a vowel, A, E, I, O, or U. Okay? Pretty straightforward here. For state in states. I called that states, didn't I? Yep. If state sub -1, remember the last letter, how it ends. I'm going to make it a little easier. Okay. In A, E, that's a comma, I, O, U, print state. That's all you need. Okay. Of course, you could, there's many ways to do this. You could declare the vowels as a list first and then say if state -1 is in vowels. You could say equals A, or, it equals B, E, or equals I, or, there's a number of ways to do this. Anything that makes this comparison validly is acceptable for the assignment. This is your for each loop. This is what I'm looking for, is this one, and print it out. Okay, so straightforward, but that's the simplest way I know of to do it, to respond to that one. 14, explain why the recursive case in a recursive function must make the problem simpler or closer to the base case. The reason is you want to avoid an infinite loop. You want to avoid infinite recursion. That's what I would be looking for. To give you credit for that one is you want to avoid infinite recursion. If you don't make the problem simpler with the recursive case, you are never going to get to an answer. Because remember, what you do is recurse, 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 recurse until you get to the base case. When you get to the base case, then you can stop. Okay. The base case is, here's a simple solution, let's go. So the reason the recursive case has to make it simpler, has to drive it closer to the base, is simply that you have to avoid infinite recursion or an infinite. Okay. I realized when I was making up the test that I was one true-false question short, so this comes in late. True or false, there can only be one base case in a recursive function. False, there can be as many as you want. We've had assignments with 2, we've had assignments with 3, we've had labs and so on. Recursion, there has to be at least one base case. There can't be 0 base cases. 0 base cases is not recursion. But there can be 2, 3, 5, 10, however many you want. There can be more than one. So that problem got stuck in there. Now, whether you get 2 shorter, simpler programming problems like you had on test 1, this is from test 2 last semester, the exam the students in my class actually took. 1 20-point, and I'm more lenient with partial credit. I haven't decided yet. I'm going back and forth. I got 2 options I'll pick, but we'll work through this one. This is a longer program that's worth 20 points, but it's still solvable. I have a data file that looks like this. It's a list of cities and towns in Louisiana and their population according to whatever source I looked for last semester when I looked this up. Okay, I took out blank spaces in multi-word names. That's why there's no blank space in New Orleans, but New Orleans had a population of 389,000. Baton Rouge had a population of 225,000. Shreveport was the 3rd biggest city, had a population of 193. Then I picked some random ones in there. Slidell, 27,000. Lafayette has 126,000. There's a little village in the middle of nowhere called Hodge, which has 400. Grosse-Tête has 818. If you speak French, that's a town whose name is actually Big Head. It's a fun place to live. I was there 9 years. I won't live there anymore, but I still have family there. What can you say? Anyway, what I want to do is I want to read in that file, those city values, and their current population. I have one name, one city per line. The population has only digits. There's no commas. There's no decimal points. I didn't put 389,000 comma. There's no header rows. There's no blank trailing rows. Write a Python program that calls a function to read the file in and convert it to a 2D list, return that list, then sort the list with the largest population first and the smallest last, then print out the name of the city with the largest population and its population. You can use sort on your code, but remember how it works. You must write the entire program, main and the function. You don't have to write comments, although, if I'm grading this is something I grade myself. I don't have the TAs do it. If you think I need to understand what you're doing, then you need to write comments. So let's take a look at what this is going to be. All right, here we go. Now, so def read file. Takes the file name with file name, read as f dot read lines, or we're going to have a list, which is going to be city list equals f dot read lines. Now, when this is done, I have a 2D list. Okay. It will have read lines, remember, creates a list. Each line is a string. So I will have at this point a list of strings. So now I'm going to have to split it. Let's see, convert it to a 2D list in the function. So now what I have to do is I have to split each line.
Professor?
Yes, question.
What do you have to write with open in the line above it?
Thank you. I knew that looked wrong. Thank you. Please, anytime I do this, it's better than trying to explain to you 2 days from now why what I gave you wouldn't work. So if you see me do that, let's fix this. Okay, so now I have a list of strings I have to split. For I in, let's do it with a for each. For city in city list. This won't work. I have to do it the other way. For I in range length of city list, city list sub I equals city list sub I dot split. Okay. Now I have to convert the population. Remember, the population is also a string. This gives me strings. So I have to convert that population to a value. And so now what I'm going to do is city list sub I sub 1, which is the second value, right? The sub 0 is the city name. Sub 1 is the population, equal float of city list sub I sub 1. Okay. And that ends my for loop. Now, this gives me my 2D list, and now I can return it. And it helps if I spell right. Now, in my main program, I'm going to call read file. Remember, my return from the file is a list, a 2D list. So I'm going to say city list equals read file. And now I'll pass the name of my file, which is cities.txt. This is acceptable. I mean, you could set that as some value anywhere and pass a variable, but this is good enough. Now I have back a 2D list. So now I can now I have to sort the list and find the one which has the largest population. Now, let me illustrate something where I said, remember how sort works. Okay, so let's take nums equal the list 5, 4, 8, 7, 2, 1. S equals nums dot sort. And if we look at S, hang on, what did you do wrong? Hold on just a second. It's easy. I don't need it as S. It's just okay. Okay, what am I doing wrong here? Hang on a second. The bottom line is sort returns, unless you use the reverse function, sort returns the list ascending. So sort returns the largest value in the last spot. Okay, so now what I have to do, getting back to the main thing, what I was trying to do here, poorly, is illustrate that sort returns the list value in the order. Here, that's what I'm looking for, silly. I don't need that. I don't need the sort. I just need nums. Here we go. So go back to this. Another live demo. Now sort that. And now look at the list. And you can see the list has been sorted so that the largest value is last. So what that was all about, that I finally figured out how to do it correctly, is I told you now you have C list is the list of cities. I want you to find the largest value and print it out. Well, if you sort it, the largest value is going to be last, not first. I had a number of people on this on the test last semester that assumed that it was sorted with the largest value first. The largest value is last. If you don't want to use sort, you can use another function. You can write it yourself. That's fine. But all that means is that if you do this, if you sort, it puts the last value, it puts the largest value last. The other thing is, remember that you've got two columns and you need to sort them both, okay? And you have to keep the city together with the value. So what I'm going to do is I'm going to say populations is the list of C lists of 1 that gives me the populations. Pops.sort. Now, pops sub -1 has the largest city, or has the largest population, and I'll just find it out, find that city. Okay, so let me comment this whole thing out. After you do this, this is one way of many to do it. C list. Sub-0. Let's try this again. There we go. And that program will give you what you want. So what am I looking for? I'm looking for passing in the file name as a parameter with open, read it. You don't, let's see, what was the assignment exactly? Sorry, Blackboard crashed on me. I'm reading the problem statement out of my off my Blackboard thing, and Blackboard crashed. So let's make sure. So okay, yeah, the assignment says call the function to read the file in and convert it to a 2D list. Now you don't have to do read lines. To me, that's natural, but you could do read or read line in a loop. That's fine either way. What I'm looking for is then you split. If you don't do read lines, you have to split the file into a list of cities. And then you have to split each line into city and population, and you have to convert the population into float. You could certainly combine these. You can combine these statements in various ways. That would be fine. Anything that does that, and return city list is the main thing, a return of a 2D list. The main program, I'm looking for call the function read file. Now you know you have a 2D list back. You have to sort, find the largest city in its population, and print it out. The one I've given you is not the most elegant way to do it. There are other ways as well, but this would work. Anything that works as functional is fine. I mean, I'm giving you a short time to do this. I'm not expecting optimized code. I'm just expecting code that works. So this is what would happen if I give you a 20.1 program. If I gave you something this complex, as I said, I've torn. My test that I've developed has two choices. One is a 20-point, write one program that looks about as complicated as this. The other one has two much shorter ones that would be worth 10 points each, and I haven't figured out which one I like best, but I have until Wednesday to do that. At any rate, that is the sample test and my answers to them, and if you have any questions, let me know. I also started the lecture by going over classes to the extent that you should be able to do Lab 10 without it that much problem. Again, in Lab 10, what you're doing is you're writing the code that goes under class box, and you're writing the code that goes under class item. And I showed you that there are about four functions that have to be defined under box, but they're simple, and two that have to be defined under items, and they're simple. And it's just a matter of straightforward getting used to the terminology. Really, with classes, it's more of an issue of getting used to the terminology than with anything else. And if you don't want to worry about the lab until after the exam Wednesday night, that's fair. You have till Friday night to do it. But if you're going to Tommy's lab on Wednesday, be ready to ask him questions and get any help. Because if you can knock it out before the test, hey, then once the test is over, you're free from this class till next. You do have until midnight tonight to do the homework if you're not done yet. One thing I wanted to warn you about in problem 3, I think, in the homework, you're writing a set of the instructions that come out with homework 6, problem 3. There's a set of steps that say if n is divisible by 15, do this. If n is divisible by 5, do this. Okay, what we want you to do is something like this. The number of steps it takes for that to fall under down the path, if it's a base case, you return 0 because there's no more steps were done. If it's a recursive case, you return 1 plus something else. Now, in that problem 3 definition, the base case is what we give you last. Okay, in the assignment, where we say if it's n is negative or 0, return 0, that's the base case. Okay, that's the base case. So when you write your code, it's easier to address the base case first. Address the base case, so check to see if it's less than 0. If it's negative in problem 3, just return 0 and you're done. You don't have to worry about anything else. Then you can write the code for your recursive cases, and you've got 4 recursive cases, right? You've got the recursive cases of what do you do if this is divisible by 15? Address that. If it's not divisible by 15, your next recursive case is this divisible by 5. Address that. If it's not divisible by 15 or 5, you have the case of is it divisible by 3? Address that. If it's not divisible by 15, not divisible by 5, not divisible by 3, you don't have to check if it's greater than 0, right? You don't have to check if it's greater than 0. You already know that because you've already addressed the base case first. You've already checked to see if this is negative. If this is negative, you've already addressed it. At this point in your code, when you're writing your if, elif, else, have to worry about, is this greater than 0? You already know it is. So address your base case in problem 3 first. If it's less than 0, do this and be done with it. If it's not less than 0, then you can address your recursive cases, check for 15, check for 5, check for 3. And if it fails all the 15, 5, and 3, you know what to do because you don't have to check to see if it's greater than 0. You already know it is. So that's a hint on problem 3 on the homework, because I know a number of people have already had problems with it, and I've worked a couple of you through that one already. That is it. That is all. I'll be available if you have questions, whatever, ask. And we will see you on Wednesday. So have a good evening, everyone. Thank you.